Okay, this is going to be a keep forever on domain and range. You will get very good at this, but to start with, it's very different. So some notation that you have to know, these squiggly brackets, these mean the set of. X is just our normal variable. This straight line is such that. This is your restriction part. So in this case, I've written X is greater than 5. Sometimes books will be lazy and they'll just write this part. We need the whole thing. And X, this means in the set of. So X is in the set of. And then this is real numbers. It could be whole numbers. It could be integers. You'll see some more of that. So come back to this when you need to. Next, domain and range, add in and function or not. We're going to do a vertical line test for that. So I'm going to start with, is it a function or not? You have done relations and functions. All of those can be made into a graph. If the graph can have a vertical line that passes anywhere through it and only touches the graph one time, then it's a function. If you pass a vertical line through it and it hits more than one time, it is not a function. Let's memorize. Okay, domain of a relation is the set of all possible values that can be used for the input. So it's the x's. It's the independent variable, and there we go with the little x. So what you're going to imagine is squishing the graph onto the x-axis and writing all the points that get hit. Similarly, the range is the y part. And you'll think of the same thing here. Squish the graph onto the y-axis and write down all the points that get hit. That's a lazy way of writing that. Okay, so we will go through these examples, and I think these will really help. List the domain and range of the following set of ordered pairs, and we're going to do, is it a function or not? So domain is the x's. So I'm going to do the squiggly bracket, x such that, and now I'm going to write them down. X equals, and when it's a small list, we just write them. 1, 0, 3, 5, and -3. The end. You don't have to write x in the set of anything if you are writing all of the numbers down. So that's the domain. And now the range. So the range is the y values, y such that y equals, and I'm just going to write them, 2, 5, 8, 9, and another 2. I don't need to write that. And now, is it a function or not? So a vertical line passing through, let's put this back here, a vertical line passing through this circle and hitting 2 points would mean they're over the same amount. So this would be like over -2 and down 5 or whatever. This would be over -2 and up 5, let's say. But our part that makes it not a function is those x's being the same. So here we're looking, do we have any x's that are the same with a different y value? And no, we don't. We don't care that we had this y that was the same. It doesn't matter. So yes, it's a function. Okay, try B and then turn it back on. Okay, so domain on this one, again, you're going to write everything. So x such that x equals 3, 0, -3, 2, -8. And I would never worry about putting them in order. Range, y such that y equals 3, 3 again, 9, and 3 again. Okay, we didn't need that extra comma there. And is it a function or not? So do we have two x's that are the same with a different y value? And we didn't have any x's that were the same. So function, yes. These are more typical of ones you're going to be using and doing domain and range of. Usually it'll be of a graph, and especially in the future. So this is where we're going to kind of imagine squishing the graph onto the x-axis and writing the points that get hit. So a part, imagine squishing all these down. So this would go to the x-axis, this would go to the x-axis, this would go to the x, right? And just squish them all onto the x, like you're sandwiching a panini. And then we're going to write down the x's that get hit. We could write every single one of them. That would be fine for this small group. But if we're at minus 100 and plus 100, we certainly wouldn't want to write them all. So we will use notation that will simplify that for us. So domain is going to be x such that, and now if I'm in between -5 and 5, so I've got -5, -4, -3, -2, -1. Oh, I guess I'm starting at 4, aren't I? -5 is here. Oh, okay, -4. Good thing I hadn't written that already. So we're in between -4 and 4. So 0, 1, 2, 3, and 4. But I could just write -4 is less than or equal to x less than or equal to 4, comma, x in the set of, and I'm not in the set of real numbers because real numbers would include everything in between these dots, and I don't have -1.5. So I have to write in the set of integers instead. Often they use the double bar, remember? Okay, so let's talk quickly about this. This, start at the x, and work backwards. X is, and if you read backwards, x is greater than or equal to -4. Well, -4, bigger, true. And x is less than or equal to 4, and true. So when it's in between, you will write it like that. So range. And now we're going to think, same idea. Squish everything onto the y-axis and write down what gets hit. So if I squish both of these, they will both hit the 0, hit at a height of 1, hit at a height of 2, height of 3, and height of 4. So I'm in between 0 and 4. Again, I could write 0, 1, 2, 3, 4, or y such that, and we always put the smallest one first, so 0 less than or equal to y less than or equal to 4. Smallest, biggest, less than or equal to, less than or equal to, all the time. Comma, y in the set of, and again we're integers because we don't have 1.5, 1.6, 1.7, function or not. And if I look, I could draw a straight line anywhere, and I would only hit 1 point. So function, yes. Okay, the difference on these is now you see we're adding the line. When we squish everything down onto the x-axis, I will be hitting all the points in between the -1, 2, 3, 4, and 1, 2, 3, 4. So now I've got domain, I'm still x such that in between -4 and 4, so -4 less than or equal to x less than or equal to 4, comma, and x is now in the set of reals because it's absolutely everything that's in between those. So reals is when you have everything. That's what it is short for, really. X is going to be everything. Range. And if I squish, again, I will have everything in between 0 and 4. So y such that 0 less than or equal to y less than or equal to 4, comma, y in the set of reals, because it's everything that is in between 0 and 4. function. Straight line, yes. Vertical line test, perfect. Okay, this extends. So when we squish our graph, let's think. So domain x such that if I squish, this will all come down and be in here. These arrow parts will get squished up and end up going, and will continue. So all of this will be my domain, everything on the x-axis. So we're going to write x in the set of reals. Easy, that's the one we like. It's the shortest to write. Range. Okay, let's imagine the same thing, squishing it onto the y-axis. And I'm going to have everything from 4 down. So y such that y is less than or equal to 4, and y is in the set of reals. Function or not? Yes. Okay, next page. Okay, give these a try and then turn back on the video and take a look. So domain, range, and we're going to do function. So if you didn't, turn it off, do it, and come back, and now we'll look. Okay, this guy, domain. X such that parabola, I'm going to imagine squishing it onto the x. This continues forever, and everything will get hit. X in the set of reals. Every parabola in the whole wide world will be x in the set of reals. Range. Every parabola that's right side up or upside down. Let's just make that clarification. Okay, range. So I'm squishing everything onto the y-axis. This is my lowest point, and I've got everything above that. So this will be 1, 2, 3, -3. Y such that y is greater than or equal to -3, comma, y in the set of reals. And function or not? Vertical line test, yes. B part, this oval. So domain x such that I'm going to squish and my furthest point will hit there on the x-axis and here on the x-axis. This is 4, this is -2, and everything in between will get hit. So x such that -2 is less than or equal to x less than or equal to 4, comma, x in the set of reals, because I do have a straight line and I'm including everything in between there. Range, y such that, and now same idea, squish everything onto the y-axis, and here will be my lowest point. This will be my highest point, so I'm doing everything in between there. This is up 1, and this is down 3. So my lowest number first, y such that -3 is less than or equal to y, less than or equal to 1, comma, y in the set of reals. And function or not. If I do vertical line, I'm going to hit my graph more than one time, so no. C part. Domain x such that x equals 1, 2, 3. All of these get used. If I had another number here, 4, and then it never got used, then it's not really part of the domain because it's not even on the graph. So, well, I'm just going to leave that guy there because it doesn't matter. And the end of those, I wrote everything, so I don't need to say in the set of anything. Range y such that y equals 2, and 6, and function or not. So on the first page, remember we decided that it would not be a function if we had two x's that were the same with different y's. So two x's the same with different y's. That would be this, also this, but this point would be 1 and 2 is what it's saying, this arrow diagram. And we also have 1 and 6 as a point. So no, not a function. Circle with center -2 and 3. So -2 and up 3. And then radius of 3. So 1, 2, 3. That puts me over here at 1 and 3. And then left 1, 2, 3. So that'll be -5 and 3. And up 1, 2, 3. So I'm going to be over -2 and up 6. If I go down 3 and back to the x-axis, so that's -2 and 0. And now I don't have a very good looking circle at all. Oh well, we'll pretend that that is a circle and that it actually hits in the right spots. Domain. Okay, imagine squishing everything down. This hits at 1, this hits at -5, and I have everything in between. So x such that -5 is less than or equal to x less than or equal to 1 comma x in the set of reals. Range, y such that, now my y values, I'm at a height of 6 and a low of 0, and it's everything in between. So 0 less than or equal to y less than or equal to 6 comma y in the set of reals, and function or not. No. Okay. On this page, do page 427, 1, 2, 3, A, and C, and then send these to me so I know that you know what you're doing on these. Domain and range is huge. Okay, good work.